Simplify expressions with rational exponents. Part 1. Now let's look at rational exponents with something other than 1 in the numerator. So generally speaking, if I had a power like a to the power of m over n, we could write that as, using our power rule for exponents, a to the power of 1 over n all to the power of m. Because if I was to multiply that m in there, I would get m over n. Well, as we saw from the previous video, that means that inside my brackets, what I have is the nth root of a, all to the power of m. So a to the power of m over n can be written as the nth root of a, all to the power of m. Or I could do this another way, which is if I start with a to the power of m over n, I could write this as a to the m to the power of 1 over n, which means that this is also equivalent to the nth root of a to the power of m. So these two expressions are both equivalent, whether I do the nth root and then the power of m, or the power of m directly on the original base a and then take the nth root of it. Either is totally acceptable. And in fact, what we're going to do is usually whatever is convenient for us for simplifying the problem. So we're going to write each of these expressions with a rational exponent. The square root of y to the power of 3, well, that's just y cubed to the power of a half, which is y to the 3 over 2. And in this next one, we have the cubed root of 2x. So we could write this as 2x to the 1/3, all to the power of 1/4, or all to the power of 4, which would mean that this is multiplying the 4 into the 1/3 is 2x to the power of 4 over 3. In this last one, we have the square root. We could represent that as a half, and then inside we'd have 3a over 4b all to the power of 3, which means we could write that as 3a over 4b all to the power of 3 halves. Now let's go the opposite direction. If we have a radical statement, if we have a rational exponent statement, let's write it as a radical so that we can simplify it. So as we saw, we have two options. Do we want to write this as 125 squared and then to the power of 1/3, which we could write as 125 squared to the 3rd root? Or would we rather do 125 to the 2/3? We could also write this as 125 to the 1/3 all squared, which would be the cubed root of 125 all squared. Which of these two options for rewriting this exponent as a radical, which of these two options makes more sense for us? Well, I think hopefully you can see that it's the second root that makes our lives a lot easier, because I don't know what 125 squared is. It's some enormous number, and whatever it is, I'm not going to know the cubed root of that. But I do know the cubed root of 125 because I know my common cubed roots. And the cubed root of 125 is 5. From there, I can say that 5 squared is 25. So I've simplified 125 to the 2/3 to be just 25. So you pick the way to rewrite in a rational exponent as a radical. You pick the way that makes your life the easiest. Now let's pair our understanding of rational exponents and radicals with negative exponents. So for that, remember that if we have a to the power of negative n, that's the same as 1 over a to the n. So in this example, we have 16 to the power of negative 3 halves. We could rewrite this as 1 over 16 to the power of 3 halves. Now we have gotten rid of our negative exponent, and we have to move on to writing this as a radical somehow so that we can answer the problem. So how would I prefer to write this? I could either write it as 16 to the 1/2 all cubed, or 16 cubed to the 1/2. And I obviously don't want to do 16 cubed to the 1/2 because I don't know what 16 cubed is. So instead, I'll do that first option. 16 to the 1/2 and then all cubed makes sense because knowing that power of a half is just a square root, this is 16 square rooted all cubed. And I know what the square root of 16 is, it's 4. So this is 1 over 4 cubed. 1 over 4 cubed. Now this is something that I can do. If I have 4 cubed memorized, good. I'll know it's 1 over 64. But if you need to double check that in your calculator, that's okay. Here's a couple more examples with some slightly increased complexity. So in this problem here, I have negative 25 to the negative 1/3. Remember that BEDMAS says exponents have to be dealt with first. So this exponent is applied only to the 25 and not the negative. So I have negative 1 over 25 to the 3 over 2. And then from here, I could write that as negative 1 over 25, the square root of 25 cubed. And I'm going to do that instead of 25 cubed then square rooted, because I know that the square root of 25 is equal to 5. So this is negative 1 over 5 cubed, which is negative 1 over 125. Moving on to the example below, negative 25 and then 3 over 2. Well, that negative now is stuck to the 25, brackets first. So all of this has to be dealt with. And I don't have a negative in the exponent. So it's just negative 25. And then I'll apply the square root and then cube it. But all of a sudden I see that I cannot take the square root of a negative number, which means that this is not going to work. There is no solution to the second example. And had I gone the opposite route and done negative 25 cubed and then square rooted, it wouldn't have helped me any, because a negative number cubed is still negative, which means I still can't take the square root of it.